a lot of vocabulary in this first little bit. So listen to me. You gotta pay attention to the words because they are all related. And there's a lot of synonyms in this unit, right? The same, something that looks very similar has 3 or 4 different names to it, okay? Because they're all slightly different, but they're closely related. So there's a lot of technical jargon in this unit that you got to pay attention to. But you can distill it down to 1 or 2 main concepts, so you should be okay. Everybody good?
Yeah.
All right. And as always, I will try to put things into regular English as often as I can. So we begin with, as you can see, 3 words right here, all of which you actually know, but they have a specific definition in mathematics. So we're going to start with them. Okay, everybody good? All right, we'll begin with what a set is. Now, when I say I have a complete set of Pokemon cards, what do I mean? You have them all. I've caught them all, right?
All like 8,000?
Uh-huh. By the way, of course, you have to be careful. Don't change in front of a Pokemon, because he might Pikachu. I know, right? Anyway, you all know what I mean when I say I have a complete set, right? I have a complete set of hockey cards for 2015. What does that mean? I have every hockey card, right? For that season. Cool? Okay, so a set is a collection of anything you can count. Okay? Anything. So we're going to give you a nice little definition that works just for here. So in this room, if I tell you that there are 2 distinct sets of people in this room,
That's prejudice.
how would you think you would define those 2 sets? Boy, girl, that works. Because you can count the boys, you can count the girls. Excellent. Is there another one?
Grade 9, grade 10.
Grade 9, grade 10? Wrong.
I have a really distinct one.
Why? Hold up. Why is it wrong, Saida?
Sure.
Am I in this room? Am I in grade 9 or 10? So that one doesn't work. If you were going by grade, how many sets would you need to cover the people in this room? 3 sets. Grade 9, grade 10, and me, who doesn't have a grade anymore. Right? Is there another set you could break this room up into?
You're gray now. There's only like 2 blonde people in this room.
You could go with hair color. Again, yes. You could go by skin color.
Dark hair.
Right?
Well, there's so many shades.
But you could. Right? Everybody cool? We could break this room up into many different sets, yes? Okay. The set I'm going to use, kids in here. That's a set. I can count you, right? And there's no other set in this universe that consists of you people at this time. Agreed? Are there other sets in this building?
Yes.
Right. Are they made up of you people?
No.
No, because you people are here. Everybody good? No, we are not going to discuss multiverse theory. That is for much higher level physics than we are talking about right now.
This is not the kind of physics.
Okay? Now, what then do you think an element is? You guys have all been in at least Science 9. What's an element? Yes, earth, fire, water. Yeah, no. What's an element? Yeah, the things on the periodic table. Why do we call them elements? They're all different, and what do we use for them to do? They're all the basics. Everything in the universe is built from those 92 things. Yes? So it doesn't matter what you have in the universe. It's built. Those 92 things are the pieces of Lego. Right? So an element is any single, I'm going to use the word datum, which is, of course, the singular of data, right? Any single datum in a set. A datum is just a piece of info. So, piece of info. So, keeping with this example, what are the elements of this set? This is the set, the kids in here. What are the elements of that? Yes. One of you guys is an element. Okay? Bradley's an element, but so is Vanessa. But they are both in this set. Understand? Now, all of you have done set theory before. You believe it or not. You probably didn't do it in math class, sadly. When I say set theory, I mean this thing. Venn diagrams. You've all done them, right? That is what we are doing. That is a set. That is a set. Each set is made up of elements. And if any cross over, they're in the middle. Now, those X's, are they elements? Yes, because they are single things that can be counted. But they are elements of how many sets? 2. The squiggly dots are elements of how many sets? 1. And the little circles are elements of how many sets? 1. Cool? Everybody good? If you've read John Green books, you spent a lot of time looking at Venn diagrams, because for some reason John Green loves to have a Venn diagram in every book he ever writes. If you are not familiar with John Green books, do yourself a favor, go out and read some. Fault in Our Stars, Paper Towns, Abundance of Catherines, Looking for Alaska, that one with the same name, which he wrote with the other guy, Will Grayson, which was good. And I can't remember his other books. My personal favorite two are Abundance of Catherines and Paper Towns, but that's just me.
I have both of those. Oh, Mr. Myers.
Okay. A relation is an association. Not quite. An association of, I just wrote of twice because Vanessa made me stop and writing. An association of elements from one set to another. And the example there would be this. All of you make up a set in this room, yes? In block B, is there a different set in this room? Yes. They are made up of different elements, yeah? But in this room, Ray sits in that desk, yes? In block B, another kid sits in that desk. So there is the relation. Do you understand? I have 2 different sets. That spot is filled up by 3 different people. 4 different people, because there's 4 classes in this room. That spot has 4 different pieces of data that could sit there. Right? If I were to put it on a graph, in block C, it would be Ray. In block B, it would be Supreet. In block D, it would be, I can't remember who sits there. And I don't teach here in block A, so I don't know who sits there. Bryce, who sits there in your English class? I don't know.
No, the other kid.
Bailey?
Bailey, yeah.
All right. So there, we've covered it. Everybody cool? So, our example would be the kid in your desk in another block. Because they're in a different set, but you share some characteristics. Got it? Everybody cool with those 3 words? Okay. Make sure I'm recording.
We always move on. We never actually say anything else.
Huh? Well, because
I'm always the one who says
I know. But I get tired of it. All right, everybody cool? Okay. This next thing here is a graph. All graphs require 3 things. Okay? 1, a title. Okay, the title is usually the nature of the relation. Okay? So this graph says it's average dog height. So what are the things that are being related? Dogs and their height. A Malamute? It's similar to a Husky. I'll show you a picture of it, because I'm going to show a picture of Corgis anyway, because nobody knows what a Corgi looks like either. Yeah, but it's because you're British.
I think I know what a corgi is.
So, that's step 1. It needs a title. Now, you guys from social studies are used to making this type of graph, and science as well. In math, the title sometimes is something like this, but more often than not, the title is an equation that you're going to put on a graph, which you did in the 9th grade, plenty of. Okay? Not all of you, some of you. All right, everybody good? Okay, that is the first thing it needs. The second thing it needs, and please notice I'm writing it twice, the second thing it needs are labeled and scaled axes. So, first of all, which axis is this? This is the y-axis. We remember that from the 9th grade, x's and y's. Is it labeled? Is it scaled? Half scaled. Okay, what would you name this side? Height. There, now it's labeled, and I told you it's half scaled. What is it in? Centimeters. This is always fun because this is where I find out who was good at the measurement unit. Because I say, what is this scaled in? And somebody always says inches, which would of course mean that a hound is 60 inches tall, which would of course mean that a dog's head was right here on me. That would be a
That's a thing.
F off big dog.
I've seen
I would be very frightened by that dog.
there's one on the street that's like that.
And of course, if it was a Malamute at 80 centimeters, that is 6 foot 8 inches tall, which would put the dog's head approximately here,
It's not a picture of that.
which is not a dog, that is a horse. So,
I've seen a dog like that.
the Russian bear dog?
No, it's Beethoven. Look, the
Yes, yes. St. Bernards are gigantic. All right, so we're cool with the y-axis. So what does that make the bottom one? The x-axis. Now, can I, is it labeled? Half labeled. What's missing? Some kind of title. Breed, dog breed, something, right? Does it need a scale? No, why? Because this isn't numbers, is it? Okay. Everybody cool? Everybody cool? Okay. So now I have to ask you, how many sets does this graph depict? Shaylee? 6 sets? A set is a collection of anything you can count.
1, 2, 3, 4, 5, 6, 7.
It's 6 elements. 1 set. What is one of those sets? Right, set 1 are breeds. Agreed? What are the elements of that set? Right. So now you guys all have to be able to draw these squiggly brackets for this unit. The old devil horn brackets from before you had emojis on your phone. When you wanted to send the devil head and you actually had to do that bracket, semicolon for a wink, greater than for a nose, and then that bracket for a smile. Right? We all know those brackets, yes. Okay? I personally, this is me. I send this bracket, this is my self-portrait. Wait a minute. This bracket is my hair, and then I send the number 8 because I wear glasses, and then I send a nose, and then because I'm often sad at you people, I send that. That's me. I'm not wearing my glasses today, but that's my self-portrait in emoticons. Anyway, I am not going to grade you on your brackets. When I do notes, my fancy brackets for sets look like that. Okay? I don't care. All right. So, our set is breeds. What are the elements? Hound. I'm not even going to write the word Chihuahua because they shouldn't exist. Shut it. I don't care that you're Mexican. I don't care that Chihuahuas are named after a state in Mexico. In nature, they wouldn't exist because a rat would eat it.
Our family, they are the family dog.
That is perfectly all right. I understand that. That doesn't mean I have to accept them as creatures.
They're very rare in El Salvador.
Because in El Salvador, things will eat them. Because in El Salvador, the people look at that thing and they say, that is not an animal that deserves to exist.
Nope, you're right.
That is set 1. That is a group of things we can count. What is set 2? Yeah, the heights. You're on a roll, Vanessa. What are the heights? 60, 12, 30, 45, 45, and 80. Yeah? So I've covered both sets, I've covered both elements. Now, is there a relation? Do the elements from one set relate to the elements of the other set? Yes, how?
Because it's measuring how big the hound is.
Yes. So if I say how tall is a hound, can you tell me? It's 60. If I ask you what dog is 60 centimeters tall, can you tell me? Yes. So these sets relate to each other. Everybody cool? Okay. If set 2 was color, could we do this? No. Because can we have a black lab? Can we have a black shepherd? Can we have a black Malamute? Yes, yes, yes. So we couldn't do it. It does not relate 1 to 1. Everybody cool? All right. So, Chihuahua works. Corgi works. I'm skipping these 2. Why? Because they're the same. If I say how tall is a lab, does it work? Yes. If I say how tall is a shepherd, does it work? But can I go the other way? Which dog is 45 centimeters tall? It could be either one. Do you know of which one I speak? No, you do not know. So because of this scenario, what we have here is what we call a relation, which we already know what it is because we defined it on the page at the top. Yes? Everybody cool? Every dog has a height, so this is a relation. Everybody okay? All right, now turn your page over.
I don't know what all of you is.
Oh, right, I forgot to do that.
There's 2 of those in the apartment building.
Oh, that's a type of husky.
Yeah, they're big huskies, essentially. They're big, hairier huskies. They're huge.
I love those.
A corgi are those things, they look a little like Labradors with stubby legs.
Oh, I've seen those. I love those.
I do not like corgis.
They're like fuzzy wiener
Wait,
dogs.
there's this thing, it's like Chihuahua or chocolate chip muffin. Like, look at this.
Moving on. When you turn your page over, you see the word function. Please highlight it. Because it has its own special rules. Okay? A function is a specific type of relation. Now, if a function is a specific type of relation, does that mean every relation is a function? No. Does it mean every function is a relation? Yes. Understand? Okay. So a function is a specific type of relation whereby, which is one of my favorite words, whereby one element in each set relates to only one element in the other set. Okay? So, coming back to what we had here. Hound relates to 60. Is that one element relating to only one element? Yes. So if this graph only had hound and 60 on it, is it a function? Yes, because it's 1 to 1. But there's Chihuahua 12, hound 60. Is it still a function? Yes, because Chihuahua relates only to 12. Corgi 30. Does that keep us as a function? Yes. This is where it gets messed up. Right? Because lab can go to two different ones. Alright? So that's what makes this a relation. Is everybody cool? You could, but that would still make it not a function. It's still a relation. Alright? So now, I want you guys to try these two on your own. You can talk to a neighbor if you want, I don't care. You have to tell me what set 1 is, you have to tell me what set 2 is, and then you have to tell me yes or no and why or why not. And I'm going to let you think about it for a moment while I sit up here and hum the Jeopardy theme twice in my head.
Takes a long time. It's less stressful. We don't do that now.
And 5, 4, 3, 2, 1, and we're back. What is set 1 here? The months. And what are the elements of that set? So we start with the squiggly brackets. There's January, February, March, April, May, June, and then I'm going to stop because I'm lazy. Everybody agree? That's set 1. Yeah? What is set 2? The days. What are the options? 28, 29, 30, 31. Those are our only options, yes? 32-day month. 30 days has September, April, June.
It's not on a 31-day month.
No. It's only on February. Okay.
I don't know how many days. there's-
So now let's check. January has how many days? 30. So it's 1-to-1 right now, isn't it? So it's a function, yeah? February has how many days? 28 or 29. Uh-oh. Is it a function anymore? Nope. Because March has what? 31. But April has what? 30. Damn. May, 31. Damn. So what is it? Function or relation? This is a relation. Why? Because the months don't have unique numbers of days. Everybody cool? Does everybody see how that works? Right? You can work the relation one way. How many days are in May? You could see that on the graph, right? 30. But if I said, what month am I thinking of right now? It's got 30 days. Could you tell it from the graph? No. You could only guess. Well, it's April or September or November, or you couldn't get it. Cool? You couldn't even do it with February, could you? Because February has 28 or 29. Excellent. Now, next one. Set 1 and set 2. What are they? Yes and no, and reasons. Now I'm going to give you a little longer with this because this is slightly trickier. Go. Bong, bong, and we're back. What are the two sets? There are names, and the other set, there's the kid, the actual kid. Everybody good? Now, here's where it gets tricky. What do I mean by names?
The sound you make.
Can they be first names? That would be one set, right? Can they be last names? That would be a second set we could use. And finally, they could be first and last names, couldn't they?
I have like 6 names.
Okay, my class list doesn't have your middle names on it. Everybody cool? All right. So, if we go by first name only, is it a function or is it a relation? It is a relation. Why? It's awesome that you were one of the ones that said it was a relation. Why? Because there's two Brads. Right? Everybody right? Everybody cool? If I were to tell a kid from in the hall, go into my room and get Brad, could he come in here and get Brad? No, because he would get two Brads.
Technically, yes.
But he would not know the Brad I wanted. Because you are not unique in this room. Everybody understand? So, in this room, it is a relation. And guys, let me ask you this. if we use only first name, it's always, well, not always, it's likely to be only a relation. Because there's almost always two kids with the same first name, yeah? What if I only go by last name in this room? In this room, is it a function or relation? In this room, it's a function. But overall, what would it most likely be? Why? Relatives, but not even relatives. How many Gills are there in the school? How many Gray Walls? Right? Not a lot of Mustafayurigs, not a lot of them. They're thin on the ground. There is another Quendak. So, okay, everyone understand? So this, again, would likely be a relation. Now, in this room, firsty lasty is obviously a function. And what would it be likely if we use both first and last? That's likely going to be a function, yes? Because it's very rare you're going to have somebody with the same first and last name in the room. Now, one time I was teaching summer school, I had two Deep Gray Walls. One was a boy, one was a girl.
Yeah, that happens. I need to.
So I didn't even have a function for first and last. And I was doing this course. So I was teaching along, no. Now, if I use first and last names, it's almost always going to be a function, isn't it? And kids like, no. Oh, crap! What's your middle names? And there we had difference. So, no, we had difference there. Everybody cool? Everybody cool? All right. So, let's move on. This next thing, please notice some more words. The dependent variable, which I will abbreviate as DV. Okay? This always screws kids up. What is the definition of the word variable?
It's like kind of like the missing thing, right? It's like a fill in the blank.
Okay. In math class, always. Bryce and Brad, what is the definition of variable? Something that can change. Cool? Now the reason in math we use the word variables when it's unknown is because if we know it, it can't change. Right? How many pens are in my hand? One. That can't change. Right? No, it can't. How many pens are in my hand? Now how many pens are in my right hand? X. Exactly. Because why? Because you don't know. It's unknown. And it can be any number from what to what?
I don't know how many you grab.
3. No.
Or 0
0 to 3. And you don't know, do you? Everybody with me? Of course, it was 0. Because all the pens are in my left hand. Everybody cool? All right. So the dependent variable, what does dependent mean? It depends on something else. So what does that mean?
So if like
It relies on something else. So what does that mean?
it changes based on that, how do you? I don't know what you want from me.
Independent means you don't need anybody.
No, we're on dependent right now. Who are you people dependent on? Who are you people dependent on? Your parents. Right? Right? Who am I dependent on? No. I have never been jobless. Right? I am independent.
But your kids.
My kids are dependent on me. Everybody got it? So a dependent variable is a changeable value which relies relies on another value. Everybody okay with that? Everybody cool? Okay. I'm going to say some numbers right now. Those numbers are, we're going to use them as a variable. When I say those numbers, I want you guys to tell me what you think those numbers are. Is everybody ready? 14, 15, 16, 17, 40.
Oh, I know what that is.
What are they?
Those are
Ages of whom?
of people in this room.
Ages of people in this room. Cool? Everybody got it? I'm just guessing that there is someone who is 17 in this room. I don't know if there is or not. I'm just putting out values.
Yeah.
There we go. I got it. Everybody cool? Everybody cool? Yeah? Yes? Okay. So, we used ages. All right? Now, 14, 15, 16, 17, and 40. That covers everyone in the room, yes? So anybody in the room that's 13?
But you're like 85.
And nobody in the room is 18? Sweet. Okay, good. Now, dum-da-dum. An independent variable is your IV, which is what? A variable whose value can stand alone. Okay? Now remember, variable is something that can change, right? So now I'm going to give you a second set of variables. Everybody ready? Brad, Joshua, Vanessa, Saida, Ray, Felix, Peter. Everybody cool? So what is my independent variable? What is that did I just do? Those are names. Because the names can change, can't they? Depending on which kid I point to, right? That's the, okay? Now, put them on a graph. It's exactly like the dogs and the height, isn't it? The graph would look like this. Okay? I would have, what would be down here? Names. Right? And what would be up here? Age. Right? Now, Brad is always going to be Brad, isn't he? No matter what, he's Brad Quendak. Doesn't matter. That, when I point to that guy, it's that guy. Got it? He is always Brad Quendak. If he changes his name, then his name becomes a dependent variable, doesn't it? Because it changes. But the name he changes it to, trout fishing in America, is still that guy. Understand? Cool? The age depends on who I point to, doesn't it? Because if I point to Brad, there's going to be an age. Right? What is it, Brad? 14. If I point to Preeti, it's going to be a different age, isn't it? And depending on whom I point to, that is going to be the age. And until I point, do you know what age it is going to be? No. But you know I'm going to point to a person in the room, don't you? Everybody got it? So, the names are the independent variable. Please notice I put them on the x-axis. The ages are the dependent variable, and we put them on the y-axis. Everybody cool? The reason we do it is simply because that's what they decided to do. It's just an agreement amongst mathematicians. I know. But somebody does usually ask, well, why do we do it that way? Just 'cause. Everybody cool? All right, now, I'm going to use similar highlighting. The domain is same highlight as the dependent variable. That is because the domain is the set. Oh, I screwed this up. I always screw this up. Sorry. No, I did it right. Sorry. I always screw this up. No, I always screw this up. The domain is the independent variable. The independent variable, in this case the names, it's any value that can stand alone. The domain is the set of elements. The set of elements that make up the IV. So if it's a set of elements, we have to write it with the squiggly brackets, don't we? And in this case, what is the domain? All our names. Got it? And the range, duh, is the set of elements for the DV, which in this case is ages. Everybody cool? Now you should have some space at the bottom of your page right now, yes? So down there I like to do this. IV equals domain equals x-axis equals one more new word, input. Dependent variable is range, which is the y-axis, which is our output. Now, please understand that this is for your memory. The domain isn't the independent variable. The domain is the set of things that are the independent variable. Do you understand? Right? But this helps you guys hopefully remember it. Everybody cool? All right. So let's turn our page over. Oh, okay. Yeah, you guys were pretty busy talking. I know you were talking about independent variables and dependent variables. That's the second time you've done a loud tattle, and you know how much that pisses me off. You don't think I have eyes?
I know you can tell if you wanted me to move.
I was giving them a chance. Now, why do you think I just said, I know you guys were talking and didn't get this down? Why did I do that? That's my warning to them to shut up or she's moving. Okay? I will be the teacher. Okay? Just like I have to tell my kids all the time. My kids have two parents. They don't need each one to parent each other. I will take care of it. Okay? You are welcome to go to 7 years of university and come back and be this person if you wish to discipline the class. Okay? Until then, it's up to me. Yes. Okay? Now, let us move on, cabbages. Now, please notice, nobody is allowed to make fun of the fact that I made these notes so long ago that the minimum wage was that low. I think it's going up to $10.65 or something.
I think it's 11.
Might even be 11. I don't know. It's too high, is what it is.
It's 10.27 or something.
It's too high.
It's too high?
It is.
Oh,
Minimum wage is not designed to be a living wage. You should not be trying to support anyone but possibly yourself on minimum wage. It is designed to be a low pay for a low skilled job. The problem with North America is we have paid people too much money for doing low skilled jobs. For example, when I worked at a mill and I picked up a piece of 2x4 and I looked at it and I had to decide if it was a nice piece of 2x4 or a bad piece of 2x4. And if it was bad, I threw it behind me. If it was good, I put it back on the conveyor belt. And for that, I was paid $17 an hour.
Yeah, it's your middle.
Can I go work there?
Right?
They also pay a lot.
That is crap. The people that work on BC ferries and take food from the window and hand it to me. They do not cook the food. All they do is move it. Are paid $18 an hour. When I worked at Subway, where I prepped the food, took the orders, brought it to the customer, cleaned the restaurant, ordered the food, supplied the food, made the food, managed the restaurant, I was paid $8.50 an hour. That is what is wrong with North American society. We expect too much pay for not enough work. And the reason we expect that is because we expect to be able to live at a very high level, which is why we get appalled when we hear about people being paid 10 cents an hour to work in a factory in Bangladesh. And yet, that 10 cents an hour in Bangladesh is more than enough to live on. But we get angry. We get angry. It is not more than enough, I know, but they can subsist on it. So we argue that everybody should be paid North American wages, which is not the case. What really should happen is we should be paid less so that when we buy a new car that is only worth $5,000, we don't need to spend $50,000 on it. In India, I can buy a brand new car for $2,500 because the market in India is bigger and they are paid less. So as a result,
They're so busy trying to survive in their environment rather than enjoying these things.
yes,
Like,
But-
I've met so many people that get paid like what you're saying, and they don't just get by, they're struggling to survive
yes,
every day.
you're absolutely right because they are paid too low. I'm not saying they're not. What I am saying is that we are paid too much in our society.
Like, even in our own backyard, there are people who are making minimum wage trying to support their family.
Exactly, but that's the problem, Vanessa. They are staying in a minimum wage job.
If you were in that position, you wouldn't.
I have been in that position. What did I do? Went to university and got a better career.
You were supporting your wife and your kids.
No, I did not have a wife and kids until I was able to support them. No, I know it's not like that for everybody, Vanessa. I'm not saying it is like that for everybody. What I am saying is that you have abilities in North America to achieve a higher wage than minimum wage. Minimum wage is not designed to support a family. It never has been. And if you make use of the opportunities offered to you in North America, you do not need to stay at a minimum wage job. Do you? No. But people don't want to go to university or whatever they need to do. Right? Or I can't. I have kids. Okay, you have kids, but there is still ways to do it. Right? My family was dirt poor. How did I go to university? I took huge amounts of student loans and worked. Did it suck? Yeah. Did I have buddies that were buying cars and going on trips to Mexico and things? Yeah. Because they quit high school, they finished high school and they went out and got a job that paid better than minimum wage, and they weren't going to school, so they could work 40 hours a week for $15 an hour, and all of a sudden they're off in Mexico. I couldn't. I could work less than full-time at minimum wage. And as a result, I could not go on a trip anywhere. I had to spend all my money on university. I mortgaged my future because I knew eventually I would need that. That's what I chose to do. And in the meantime, I did not choose to get married or have a family because I knew I could not support them on $6 an hour. Right? When I became a teacher, after 10 years of teaching, and I got my bills paid down a little, my university paid off a bit, we had children. Right? Were we behind a lot of our friends? Yes. I bought my first house at 33. I have friends that bought their first house at 20. That's just a choice I made, right? Did I blame anybody? Did I get mad at the world because minimum wage was too low? No, because I knew that was a stepping stone. That's not the end. And that's the problem, right? You can only, how much should you be paid for a minimum wage job? How much skill is really involved? Right? There just isn't. You're pushing a broom, or you're flipping a burger, or you're selling clothes, right? It's a big argument, and it's going to take more than an 80-minute math class. But the point is, you should be paid for skilled work. End of discussion. If you're skilled, you should be paid more, right? If I am working at a 7-Eleven as a cashier, why am I being paid $15 an hour when I was working at 7-Eleven? $15 an hour less than the person working as a cashier on BC Ferries. Right? Why are they 18 and I'm 6? We're doing the same job. Are they paid too much or am I paid too little? I feel they are paid too much because cashiering is not that skilled a position, especially now. Beep, 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 beep. When I worked at 7-Eleven, we had to memorize the prices at least. Right? Should you be paid that much? My buddy's wife worked at the deli counter in Safeway, $22.75 an hour to work at the deli counter, cutting meat. Guess what I did at Subway? Ran meat through a meat cutter for $6 an hour. Is she overpaid or am I underpaid? No, because there is no skill to this, Nick. None at all. That's flick a switch, plop, meat, push. Pull, push, pull, push, pull, push. That's $6 an hour worth of work. Right?
That would be pretty tired. You didn't have 6 hours.
Again, let's compare it to a doctor. A doctor should be paid a little more, because if he screws up, I die. All right, this is another argument for another day. We have wasted plenty of time on it. You all have your opinions, I have mine. Do I think minimum wage is too low? Yes, I think minimum wage is too low because our market is screwed up.
Yeah, because it's so expensive to live.
Okay, if our market was sensible, then no, minimum wage would be fine. Now, I'm going to ask you guys to do this job. A, B, and C. Which is independent, which is dependent. We're only going to do A right now. I'm going to shut up for 20 seconds. Talk to your neighbor if you wish to. Do as much as you can, but we're going to do each one separately. So, A. 20 seconds, go. Bong, bong. And we're back. What is the IV and what is the DV? So, first of all, I have to decide what are the two variables. What are the two things that are unknown? So there's two sets here, yes? Set one is what? What is one of the things we are counting? Hours worked. What is the other thing we are counting? Pay. Right? Everybody agree? Okay. Which one of those can stand alone by itself? Pay?
The pay doesn't change. The hours
All right. You guys walked into this room at 11:45, yes? It is now 12:45, yes? Did an hour pass for you? Excellent. Were you paid? No. Did that hour still pass? Excellent. Did that hour pass for me? Yep. Was I paid? Yep. So which one of those two stands alone, hours or pay? Hours. Why? They're going past for everybody no matter what. Hours are always being counted. So this is our independent variable. Why? Because hours pass regardless. You all just sat here for an hour. You were not paid. I was. Right? How much was I paid? That is my dependent variable. Because without hours worked, there's no pay. Understand? I have to have a job that I go to get paid. Everybody with me? Now, domain and range. This is where that little chart we made on the last page can confuse you. The domain is the hours that I work, yes? So what is the set for domain? First of all, I got to make it a squiggly. What's the lowest amount of hours I can work? No. 0. Right? What's the most amount of hours I can work at that wage before I start getting overtime? Does anyone know?
8.
In a week.
40.
40. Excellent. So 40 because we're doing pay per week, right? So 40 is the maximum. Hours are in the middle. Now how do I draw this? My hours have to be between those. So we draw it like this. 0 is less than or equal to my hours. Right? Because that's the littlest I could have worked. But my hours have to be less than 40. Everybody got it? Everybody cool? Now, I can't actually put that line there, the squiggly bracket, yet. Why? Do you think? Do I get paid to the second? No. The best I get paid is to the quarter hour, yeah? So there's restrictions on my hours here, aren't there? If there's restrictions, you have to write them in. You put a straight line, and then you start saying the restrictions. Okay? Your hours, that symbol, it's like an E, which stands for is a set. Your hours is a set of what would be the best I could hope to be counted as. Quarter hours, right? Your hour is a set of quarter hours. And then we would put our squiggle in. Everybody understand? Now, what if I said your hours are a set of natural numbers? What would that mean?
Those are the square numbers, right?
The counting numbers. 1, 2, 3, 4, 5.
Oh.
Right? Or 0, 1, 2, 3, 4, 5. Okay, do you understand? That's a restriction. I could only put in 0, 1, 2, 3, 4, 5 up to 40. I couldn't say I worked 5.25 hours. Everybody got it?
Yeah.
All right. So now let's see if you really get it. What's my range? What's the lowest amount I can be paid? 0. And then my pay, because my pay has to be greater than 0. And what's the most I can be paid? How do you figure that out? 40 times the wage, which is what? You get out your calculator, you find it's 380, right? Are there restrictions?
Yes.
Yes, what?
Half the time. Like quarter time.
I can only be a quarter, right? So my pay must be a set of multiples of 950 times the quarter. Everybody cool? Everybody cool? Is it a function, yes or no? Alicia says yes, she's right. Why?
Because if for every hour, there's not going to be, so let's say it's 2 hours, it's not going to be $9.50.
Yeah, it's gonna be $19. 3 hours, it's gonna be $28.50. 4 hours, it's gonna be $38.
So if you're not going to have that double,
You're never gonna have a double. Nice. Yes, because every input, which is an hour, gets me a different output, which is pay. Cool? Now, that's a real life example, yeah? Right? Now, this is a math class, so we got to do a math one. What do you know about numbers that are written like that? You remember it from grade 9. What does that mean? Alicia?
X and Y.
That's an X and that's a Y. And then XY, XY, XY. X's are what? The domain or the range? Look on your notes. What is the domain, X's or Y's? X's. So what is my domain here? 1, 2, 3, 4. Agreed? Okay. What is my range? 3, 6, 9, 12. Now, check for relation. 1 for an input gets me how many outputs? 3, even. There's 1 input, 1 output, yes? 1 to 1, 1 to 1, 1 to 1. Function or relation? Function. Because it's 1 to 1. Everybody cool? Great. Let's do the second one. What's my domain? It's a set. What's the first one? 1, 0, negative 1. We don't need to write 0 again because we've already got it. Cool? And what's my range? Zero, 1, and negative 1, yeah? Now let's check. When I input 1, how many outputs do I get? 1. 1 goes straight to 0, yeah? When I input 0, how many outputs do I get? I get 1 and negative 1, don't I? 2 outputs. So is this a function or a relation? That's a relation. Everybody cool? We're stopping at D. So you guys try C. What's your domain? What's your range? And then tell me what it is. Who would like to try it? Domain first. Alicia.
2, 4, 6, and 8.
Who do we appreciate? Myers, Myers, rah, rah, rah. And what's your range?
3, 5, 7, 9.
Function or relation? Function or relation? Function. Why? Because it's 1 to 1, correct? Okay, now, see if you can do it with a graph. What is my domain? Where do the domains live? On the x's. So there's one here, yeah? There, because there's a dot. There, 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 and there. So what are those values? What's this one? Negative 3, negative 2. What's next? 0, 1, 2, 3. Agreed? Everybody cool? Okay, notice we went from smallest to largest, yeah? Okay, now let's do range. So my range is on the y's, yeah? So there's a y, a y, a y, a y, I made an x, a y, and a y, correct? What are they? What's the lowest one? Negative 3, negative 2, negative 1, 0, 1, 2. Correct? Now we got to check the relationships. When I go to negative 3 on my input, negative 3, how many outputs do I have? I have 1. Is that okay? So at negative 3, we're okay. Correct? Everybody good? When I go to negative 2, how many outputs do I have? I have 1, 2 outputs. Is that ever allowed? So that's where it dies. So is it a relation or a function? That one is a relation. Because at that input, I'm dead. Now let's check the others, just to show you what I mean. What's my next input? 0. How many outputs do I have? 1. That's okay, correct? My next input is 1. How many outputs do I have? 1, because it's right there. So that one's okay. At 2, there's only 1. So that one's okay. At 3, there's only 1. So that one's okay. If these dots weren't here, is this a function? Yes. But because those dots are here at negative 2, and I have output 1, and I have output 2, it's not a function. Everybody cool? Okay, now listen. You have a test tomorrow. I do not want you to do this. First of all, you can cross out worksheet. I do not want you to do 270 and 294 tonight at all. Study for your test. Tomorrow, if you finish early, start working on those. When do these need to be looked at? By Wednesday. Cool? And you guys got like 8 minutes left right now, and then class goes to 105. It's 12:58. Okay, regardless, you're here for a little bit more time. Then I don't know if you're going to your next block first, or do you stay here and we take you? I don't know. I'm waiting.
Wait, does the assembly go to every block? Are we even going? I thought it was already started.
I am going to check my email to see if there's been any more sent.
Are we skipping last block?
Yes.
Yay! I hate the learning center. People there are so annoying.
This is going to be such a short week. We haven't even done anything. And Thursday, Friday.
What's this? Oh, we got 2 hours early because all Friday is...
This is like when they had the strike on. I was on the project and just played poker.
Well, you should see Tristan and Thomas.
Where's my headphones?
Mr. Boyd's class, you're doing this.
Come on, the class is very loud.
No, well, I got it in my last one set at the back. All of them are just sitting there playing pool.
Why do they play pool in the play? Because I know, but
Yeah, all the chairs need to go up, please.
I don't want to have to go by computer.
You don't have an option.